that that's a more intuitive approach. But obvious, and by the way, intuition doesn't really lend itself to be written down, because if I were to try to write steps out for what I just said, it would be like, all right, now do this, now think about that, wonder what you're gonna have for dinner, and then come back to the problem, and then answer the question and like smile. Like there aren't any meaningful steps there. But that's the kind of process that you kind of pick up on when you do this kind of stuff over and over again, because you're like, oh, it's always just that. All right, so why don't I just do that? You know, and it doesn't seem like it makes much sense, but when the time comes, you'll know what I'm talking about. So my inner function here, I call it u, is equal to 2x. Derivative of that, du, would be equal to the derivative of this guy is 2. And since I'm going to move the dx over anyway, I just do it. All right, inventory time. Secant squared of, now it's u, dx. All right, I have inconsistency within my arguments. I have a u and I have an x. Can't have them both. It's got to be one or the other. For a u substitution problem on a test, if you've tried every possible way to define u, and you keep coming up with integrals that have u's and x's in them, that means one of two things. The first one you already know. You screwed something up. Assuming you didn't do anything wrong, it means you're using the wrong method. Right? It means u substitution is not appropriate. All right. In this case, I can do something because I have this relationship here. My inventory control here is telling me that I need a dx. I have twice that. I don't want twice that. So let me just jot it down over here. Du equals 2x. 2 dx, sorry. I don't want the 2. So let's divide out the 2. So 1/2 du equals dx. So it's the 1/2 du that's going in. Secant squared u, and you could write it as an intermediate step if you want, at least till you get the hang of it. That multiplication symbol is getting out of hand. Oh, that's not even a multiplication symbol. Come on. There we go. 1/2 du. Write that intermediate step until you get comfortable with it. Then rearrange. You pull the 1/2 out if you want. It doesn't make a difference. Then you can anti-differentiate. The reference page will be helpful until you get the hang again. This is 1/2 tangent u plus c. That's equal to y. Now, we redefined the function that was of the form f of x into y equals, so let's go back and make that f of x. This differs from what we were doing because it's much easier. No, that's not true. This is a terrible problem if you don't know your tangent derivative rules. Now, you get to this step, and you're not even at the point where you're saying, if only I knew that rule. You're like, it's more like, is there a rule for that? Like, it's the difference between the two things. So know those rules is really important. But this differs really from those other problems because we have some condition that we can apply. All right. So going back to the original framework, it says it's passing through the point pi over 2 comma 2. So what this is telling me, the coordinate pi over 2 comma 2, I have an x, and I have a y. Y and f of x are the same thing, so I'll call this f of x. So 2 equals 1/2 tangent of, love me some me. That is not a movie reference, but it is a very famous reference. Anyone? I love me some me. I never swapped out the U. Anyway, that's my bad. I dropped the ball. Terrell Owens. Famous football player. Not as good as he thinks he is. you're a Giants fan, you know exactly who that is. Especially in 2002 and early January. Oh, that was the closest I came to, like, over a sporting event. Like, sometimes when things go bad, you, like, start tearing up. You're so frustrating. That was the closest I came to, like, full-on sobbing and heat. When you blow a 24-point lead with, like, 13 minutes to go in the game, it's like, it's inconceivable. Anyway, sorry. The U had to go back to 2x, because that's what U is equal to. Then we apply the condition, and then go from there. So we have 2 equals 1/2 tangent of pi. Even if you don't know trig, calculator can handle that one as long as you're in the right mode. 2 equals c, because tangent of pi is equal to 0. All right, so my general solution to the differential equation, f of x, 1/2 tangent 2x plus 6. Yeah, I know. But I figured since I spotted you the first 30 pages, you could spare a piece of loose leaf. And put it in as a typo. What's that? Yeah, thank you. Thank you. You caught up. But yeah, somebody could take that as a typo if you need more room. Because I got infinite space here, as you know. Well, like, it fit perfectly on mine.